girls. So you already have watched the videos about how to solve equation using inverse operations. I hope that you have remembered from year 7 how to do this. So in these videos, what I'm going to do is a lot of examples, because as I said before, this is about practice and about developing that algebraic muscle, six-pack in algebra. So it's about working out more exercises so that we become very fluent in doing them. So as always, please remember to pause the video, try to do it yourself, and then watch the video and see how you go from there. If you have any questions, you let me know. Okay, so I'm going to insert first here. No, I have to go to year 8. There we go. Okay, this is our first example that we're going to be working on. So I'm going to put it in grid paper because I want you to work this out, and I'm going to be modeling the way that I want you to work it out. Okay, so in your book, you always copy your question. Always. Okay, so question A, I'm doing it in red to distinguish it from what I'm doing. So I have P, take away 5 equals 11. So I know that you can work this by inspection, just by working out in your head, but the question says solve these one-step equations by doing the same on both sides. So doing the same on both sides, it means inverse operations. So to do this, I'm going to use something here. Good. Okay, so remember that when we're solving equations, we have to use BitMaths backwards. Okay, so I have here my addition and subtraction is the first step that I have to take care of, then multiplication and division, then indices, and lastly brackets. Okay, so that means that if I'm working this one first, what I have to do is undo what is happening to P. So P is being subtracted by 5, so I have to undo that. How do I do that? I have to add 5 both sides. And when I do that, then this becomes 0, and then it's P is equal to 16. And I put a square around my answer. So things that I want you to notice here. We work downwards. The equal sign is aligned, okay? And I'm working downwards for my solution, never to the side, never. And I'm going to be checking your notes, okay? Always downwards. So I have P equals 16. Wonderful. Let's do question B. Question B is X divided by 6. Remember, notice what I'm doing here. I'm using the first square, the first grid here to put the X, then I'm using my vinculum and 6. You see how I'm using 2 squares to use my fraction. I don't want you to have all squishy like this, because then that's not going to be clear, okay? So X divided by 6 is equal to -2. Wonderful. So again, following BitMaths backwards. So first thing that I have to do I have an addition and subtraction? No. Then I have multiplication and division. Yes, I have X. What is happening to X is being divided by 6. So I have to undo that. And to undo that, I have to multiply 6 both sides. When I multiply this by 6, this doesn't look very clear, but I'm going to write it here. Times in by 6. Why am I doing that? So you can see more clear that when I'm doing this, I can cancel this 6 and this 6. That's why I have left with 1x here, which is equal to -2 times 6 is equal to -12. And that's my answer. Wonderful. In the next video, I'm going to do more examples.